Hey guys, here we go. So tonight we're going to talk about other types of inequalities. So other inequalities. And in particular what we're going to be talking about are absolute value and radicals. Alright, so we've done what type, well, let's think about what we've done so far. So we have done polynomials, inequality, right? Polynomials. And we've done rationals, which are the fractions. Now we're going to talk about absolute value and we're going to talk about the radicals. So let's look at a problem. Let's call this f of x equals x minus 2 over the absolute value of x plus 3. So once again, when we're doing these problems, I got to find the important numbers. I need my important numbers. Okay, these are my critical values. Alright, so when you look at this problem, hopefully when you look at this problem, you see that there's a number up here that's going to be like my root, and there's going to be like a number on the bottom that's going to be like my undefined. So what would make this go away on the bottom is hopefully you see that negative 3 is some kind of critical value, and that you see up on the top 2 is an important number also. So this is actually kind of easier compared to those other ones that we've done rationals. So I'm going to make a sign chart. Okay, so we'll make a sign chart. And so here's my sign chart f of x. I'm going to put on my two numbers I really care about, my negative 3 and my positive 2. And I could do this without a calculator, right? So we can just, and negative 3, that makes it undefined, so it has to be open. 2 is a root, so I can close it. And I can just plug in numbers and see like what happens here, right? So like if I plug in a number like, right, if I plug in a 0, let's say, well, negative 0 minus 2 is negative. So that's negative. 0 plus 3 is positive. Negative, positive makes a negative. Sorry, I faded out there for a second. Let's check bigger than 2. Let's say 3. 3 minus 2 is 1. 3 plus 3 is 6. It's something positive. So that's positive. And check on this side, something like negative 4. Right? Negative 4 minus 2 is negative 6. Negative 4 and 3 is 1. That's a negative. So that's a negative also. Now, we got another one of these weird things, right? We've had this now like 3 times in a row in these videos, where if this was solid, it would have been double root where it bounces off. But once again, it's undefined, it's a vertical, and what's going to happen, it's going to be like one of those like volcano drainy looking things. So they didn't ask for the graph though. And actually we didn't ask for anything yet. So let's put a question to this problem. So where is f of x greater than or equal to 0? All right. So when I say greater than or equal to 0, we're looking at positives, and so it's, hopefully you can see, well, that's pretty easy. It's just 2 to infinity. 2 up, close at 2, open on infinity. If I said where's f of x less than 0, that's the negatives. So I would do negative infinity to negative 3. And these are opens, and then bounce again, negative 3 to positive 2. And I'm going to keep the 2 open this time because the inequality doesn't have an equal sign. Now, I threw it in a calculator, right? So I could have done that without a calculator. I did throw it in a calculator just to check, right? So 2 is a root, and a positive means above. And then, what's that number? Negative 3. 1, 2, 3. That makes it undefined. And my y-intercept would be negative 2 over 3. So it's somewhere over here. And it looks something like this. And it goes down. And then on this side it goes down also. Like this. Right, x, y, f of x. Let's take a look at another one. Alright, so let's look at a radical. So let's do radical 5x plus 4 is less than or equal to 8. Alright, Alright, so radical 5x plus 4 less than or equal to 8. Well, you've done radical equations. You haven't done radical inequalities. You've done radical equations. And so, first off, solve like radical equation. You've done this. So what we do is you'd square both sides, right? So, right, put a square on this, so 5x plus 4. And you square the other side, 8 squared. The square and the radical cancel, so I get 5x plus 4 is less than or equal to 64. And then you just solve it, keep going as if it was like last year, and you just keep on going. So 5x less than 60, divide, x is less than 12. That's true. That's true. But what we did a lot this year, we were talking about you have to watch out for the inside, right? We're talking about domain. So this inside has to be greater than or equal, right? Because look, I'm looking at where is this number? It's less than or equal to 8. Well, it can't go too much less because it can't go to negatives. So I got to figure out where does this bottom out. Well, if I say, where is it? Oh, x is less than 12, so that's important, so I need that. And, less than equal, excuse me. And now I got to worry about this inside. Now look inside. Because I don't want this to go imaginary. I got to be careful. So x is greater than or equal to negative 4/5. What? How do you get that fast? Well, let me look at that again. So 5x plus 4 is greater than or equal to 0. Move over the 4, divide by 5, and I get negative 4/5. So it's saying this. It has to be bigger than negative 4/5, and it has to be less than or equal to 12. So it would be negative 4/5 to 12, and I'm allowed to equal those so they're both closed. Now, you could graph this thing. There's different ways to do this, but that's pretty much it. Now, what if it said it wanted to be greater or equal to 8? Okay. Well, the answer would be x is greater than or equal to 12. And I wouldn't have to worry about this 4/5 because any number that I would plug in bigger than 12 is automatically going to be bigger than negative 4/5. So I don't have to worry about that bottom edge. The way it is, you have to look at the problem and work with the situation you're given. So that's how you do a radical inequality. Have a nice night.